Go. Hello, everyone. My name is Solomon Amerson.
My name is Maximus Agubuzo.
And I'm Haley Arzu.
And together, our group project is that we're going to we made a simple computer that does basic calculations.
So for our simple computer, for the micro instructions, we have going from left to right, 8 bits for the next address, 3 bits for the ALU to do either addition, subtraction, compare A to Z0, compare A to B, multiplication, division, and or. Then the next 3 bits are for memory to do read, write, or fetch. The next 2 bits are for the B bus to access PC, MBR, MDR, or AX. And in total, that gives us 14 bits.
Okay, so we have, let me share my screen really quick. Oh, this is taking time. Sure. So this is our first code part, our segment from our first part, where we had a list of 5 integers and we had a counter which is equal to 0. And then we wanted to iterate through the loop at O of n time and just essentially add the current index of the list to counter, and then at that same index multiply the value of the list at that index by counter as well. So it's counter plus equal 8i and then times equal 8i. Just keep that in mind for the future explanation that I'll give right after this. But the way that our code works, and I'll show the output first. We have AX, which gives what's currently happening in memory. And then we have the PC, which shows the next memory that's going to run through the AX. And then we have our counter end value, our number of cycles that occurs as our program runs, and the number of instructions that also occurs through our RAM. Yeah. So the counter is the same counter from over here. So this would be the end value of it. And if we were to run this program, I'll show the output for that in a moment. But yeah, the way that the code works is that we have a generator, and the generator is used to get the number of cycles, update the output file, and then update the counter. Again, I mentioned it was O of n time because since the code is not asynchronous, you're not going to see any updates real time because it happens too fast. It is happening real time, but it's too fast to see. And I didn't slow it down simply because of time. And then anyways, our output, or then we have a simulator helper, which is called many times in the generator, which is depicted by this ... line or whatever. We have the simulator helper, which holds different values such as the RAM and 3 different input lists. So like 3 of these, because we were required to have different input data sizes. So this is our generator, or the code starts in the init, and then we go to our generator method where the output is updated and the counter is updated and the cycles are counted as well. This right here is from our sub project 1, which is this right here. It's the same exact thing as we were instructed to have, like show the first example inside of our code. And if we were to use list 1, which is from our simulator helper, which is a list of 1, 2, 3, 4, 5, same as our first example, the output that we would get will be depicted in a second. Oh, okay, will be depicted in a second. which is 645. And that's for counter plus equal the index, current index at the list, and then counter times equal the current index in the list. And then also the cycles are counted right before that's done. And for the cycles to be counted, we have a cycle info map, which maps each micro instruction without the memory. Yeah, without the memory. And it gives it the number of cycles that was required. For example, the load was 6 cycles and the add, well, the add is 3 plus main 4, and then the load is 5 plus 1, 6, and same for store, except 7. And then subtract, the multiply, and our if, which is this last one right here. And yeah, that's essentially it. I can lastly just show the final third list. Oh, I already showed that. I can show the second list, which is these numbers here. And then run this as well. It's a giant number. Yeah. So that is that.
All right. Thank you for your time.
How do I end stuff?